algebraic expressions. In this lesson, we shall learn about the concept of like terms. We already know that algebraic expressions can be made out of 1, 2, 3 or more terms, each term being separated from another by a plus or minus sign. Well, before we get into the real understanding of this concept, let's have a look at these terms, 2a and 2b, 2a, 4a, and on. And what we're saying is we want to compare the terms which are adjacent to each other. These are all individual terms. And we want to just see whether they're like or unlike. Well, this concept is so simple. It is a bit like looking at the surname of somebody. A in this case is the surname. B is the surname. So even though both of them are called Peter, let's say the two is Peter, one is called Peter Jones and one is called Peter Jackson. So because the A and the B are not the same, then these two are what we call unlike terms. However, when you compare the 2a and the 4a, then you see that they are like terms. They are like terms because they are both having the same variable, a here and a there, and it doesn't matter that the coefficient is a different number. What makes them like terms is the variable. When we get to this third one, it would be easy to make the mistake of thinking that maybe they're somehow like because they both have x in them, but no, they must be exactly identical in order for us to see them as like terms. So 3xy is not like 3xz. So these are not like terms. When we get to the next one, 8xy and 9xy, yes, they are like terms because xy and xy are identical. And the last one, look carefully, 3x squared y and 3xy squared, they're not like because x squared is not the same as x. So what we should understand from this is that we say that algebraic expressions have like terms when they are exactly the same in their variables. When they are single variables, it's very easy to compare them. But when you have more than one variable together, then you have to make sure that they are exactly identical. So in this case, xy and xz are not like terms, but xy and xy are like terms. Well, if you understand this concept, let's have a go at some questions. I'm sure you'll get them right. Take your time to look carefully. If the variables are exactly the same, then the terms are like, and if they're not, then they are not like terms.